software engineering, quality engineering, test engineering. The word engineering is permeating itself throughout the software development lifecycle or the software test lifecycle. Does it really have any meaning in a software context, or is it just a bunch of mumbo jumbo to make us feel better about ourselves? I've been reading some stuff recently from some analysts and bloggers and things like that about quality engineering. And it's a subject really near and dear to my heart because I do get involved a lot with things like functional safety and software security, where we can't simply test our way into a better world. We have to actually fundamentally build something better. And it's funny because if you read definitions about quality engineering, they'll all talk about how we're trying to use some kind of a feedback loop and get to a point where we're producing a better product. But then they tend to heavily focus on things like peer review, making sure we have good test coverage, improving test data management, test maintenance, testing earlier, more thorough testing, more frequent testing, testing to the left, shift left testing in development. But it's all just testing, right? Like people talk about, if you want quality engineering, you have to do continuous. It's like, I don't know that continuous has anything to do with quality engineering. I do firmly believe that if you're going to succeed at continuous, that you have to do quality engineering. Fundamentally, continuous software, continuous development, continuous integration, continuous deployment just means that you've automated your entire process to the point that you can release comfortably with some level of automation. The problem is that if we start doing that, it'll just automatically reproduce whatever bugs we have in the software. If we make that go earlier, we'll find the bugs earlier, but we're still just producing bugs. If we make it go faster, we'll produce bad software faster. The funny thing is that when people talk about continuous, whether it's continuous development, continuous deployment, continuous integration, they talk about this infinity symbol. And they always show these various phases. And there are no canonical set of phases. So if you see them change a little bit from time to time, know that that's because it's not engineering and it's not well defined. But somewhere in this little infinity sign, the reason that we don't use a development cycle circle is that we have this infinity, which brings us to a feedback loop. And when we talk about the feedback loop, again, we end up with mumbo jumbo, and it talks about user experience and user acceptance and do users like the product and use the product. And again, valid concepts, but they have nothing to do with getting to quality engineering. They're simply making sure that we have a product that users want to use. So the thing I wanted to point out is that simply testing earlier, testing more, doesn't mean that you're doing engineering. And in fact, Deming said, cease dependence on mass inspection. If you don't know who Deming is, you're not doing quality engineering. Dijkstra said that if debugging is the practice of removing bugs from software, coding is the practice of putting them in, which is also pretty accurate. And again, if you don't know Dijkstra, you don't know quality engineering. I guess the biggest point is that the feedback loop shouldn't just be testing earlier and finding more bugs earlier. It should be about changing what we do. And in some cases, what we do might be a product redesign, it might be a different framework, and it might be actually different coding. And in fact, in other aspects of engineering, we use the best practices as embodied by a set of standards to make sure that we're doing something that we can rely on when it's deployed in the real world. We build a bridge, we don't drive trucks over it that are bigger and bigger until it collapses and then rebuild it and then say we know what the load limit is. We build it according to known principles that will have known outcomes. And with software, we do have security standards, engineering standards, safety standards, reliability standards. And we have static analysis tools as a tool to deploy them. But over the last 20 years or so, most of the industry has shifted to a capability in static analysis that's called things like flow analysis, data flow analysis, that's really good at finding bugs. So it's a form of testing. And at the time that they've adopted this, many institutions have given up on the engineering side of static analysis, where we, instead of trying to find a bug early, we say, well, fundamentally, if you code this way, you can get uninitialized memory, and if you code that way, you can avoid uninitialized memory. If you code this way, you get buffer overflows. If you code that way, they don't happen. If you code this way, you get tainted data like SQL injection, cross-site scripting. If you code that way, it doesn't happen. That kind of thought process and that approach is the engineering approach. How can I stop using dangerous things in the language, using dangerous things in my code, and fundamentally, how can I stop putting so darn many bugs in my code in the first place?